One small arithmetic mistake in your navigation calculations can literally cost you valuable exam points. And out there in the real world, it causes serious airspace deviations. So do you know the exact order to solve a navlog without falling into the examiner's traps? Well, let's fix that today. Mastering the navigation log isn't just about getting the right answer. It's about improving your speed and precision under immense time pressure. This is absolutely critical for passing your ATPL general navigation exams, and honestly, it's exactly the kind of structured thinking you need for real cockpit operations. Today, we're breaking down how to complete a navlog efficiently and accurately.
Here's the game plan for this explainer. We're going to build your knowledge step by step through the foundation, the workflow, speed, distance, and time, fuel management, and finally, some mental hacks and common traps.
Okay, Section 1, the foundation, the navigation triangle. Before we even think about crunching numbers, we really need to understand the fundamental forces acting on our aircraft. Visualizing the wind's effect is the bedrock of all flight planning.
Let's clear up the biggest source of confusion right out of the gate: track versus heading. Track is your actual physical path over the ground. Heading, on the other hand, is the direction the nose of your aircraft is pointing, which you've corrected to fight the wind. Believe it or not, mixing these two up is the #1 most common mistake students make, and it completely wrecks their navigation questions.
And the triangle of velocities brilliantly illustrates why. By applying the wind vector to our true airspeed, we get our ground speed and our drift angle. Think of it like swimming across a fast-flowing river. You literally have to point your nose upstream just to travel in a straight line across to the other side. It's the exact same concept in the air.
Moving on to Section 2, the workflow, our step-by-step solution. Because solving a navlog isn't just math, it's about following a highly specific sequence without ever skipping ahead.
So here's the standard VFR flight log. You really need to treat this as your ultimate organizational tool for dead reckoning. In the cockpit, this keeps you ahead of the aircraft. And in the exam hall, it keeps your math totally organized and stops you from using the wrong variable.
The absolute crucial point here is following these chronological steps. Step 1, find your distance. Step 2, apply the wind. Step 3, calculate ground speed. And Step 4, determine your ETA. Now, why do you think pilots and examiners care so much about this strict order? It's simple. Skipping ahead guarantees arithmetic errors when you're under pressure. Establish this workflow, and you instantly protect yourself from silly mistakes.
All right, Section 3, speed, distance, and time. Mastering the math. Let's shift our focus to the core mathematical calculations that dictate exactly how long a leg of your flight will take.
Here's your foundational formula. Ground speed equals distance divided by time. But pay close attention here because I'm going to give you a massive exam tip. Always, always verify your units match before doing any math. If your distance is in nautical miles, your speed absolutely must be in knots. Mismatched units are a classic, deliberate trap designed specifically to catch you out. Now, let's look at how we do this mechanically. On your navigation computer, or whiz wheel, you just align the 60 index on the inner scale against your ground speed on the outer scale. This immediately allows you to read off the time required for any given distance without having to do any painful long division on scrap paper.
But let me ask you a question to get you thinking about real-world variables. What happens to our ETA if the headwind suddenly strengthens mid-flight? Take a quick second to think about the impact of that. The answer? You arrive late. If you get to a visual checkpoint after 8.5 minutes instead of the planned 7.5, well, your ground speed has changed. You have to continuously recalculate your actual achieved ground speed on the nav computer so you can update your ETA for the very next waypoint.
Which brings us to Section 4, fuel management, the final calculation. And let me tell you, this is why getting that ground speed right is literally a matter of life and safety, not just passing your exams. Your fuel planning directly depends on your time en route. On the outer scale of the nav computer, we simply align our time with our fuel burn rate to find the total fuel consumed. Think about it. If your calculated time en route is wrong because of a bad ground speed calculation, your fuel calculation will be completely wrong too.
And this leads perfectly into a massive real-world operational hazard: U.S. gallons versus liters. American-made aircraft often calculate fuel in U.S. gallons per hour, but European Bowsers deliver fuel in liters. Exam trap warning right here. Failing to convert these units before calculating your load will either leave you dangerously overweight for takeoff or completely starving for fuel mid-flight. Neither is a good day out. Section 5. Mental hacks and traps. Let's speed up your workflow. To help you avoid the traps we just talked about, let's look at a few shortcuts professional pilots use to verify their mechanical calculations entirely in their heads.
First step is a classic known as the clock code. Just imagine the minutes on a clock face. 30 degrees of crosswind gives you roughly half the wind strength as a headwind. 45 degrees gives you 3/4, and 60 degrees or more gives you the full wind strength. It's a genuinely brilliant mental hack to quickly double-check that your flight computer answers actually make logical sense.
Speaking of the number 60, let's look at one of the most magical numbers in all of aviation. This is the legendary 1 in 60 rule. Basically, if you're 1 nautical mile off track after flying 60 nautical miles, you have exactly a 1-degree error. Can you guess why this is so insanely powerful for a pilot flying solo? Because it lets you calculate your correction angles purely in your head. That means you keep your eyes outside the cockpit where they belong instead of buried down in a calculator. Section 6, Common Exam Traps. Don't lose those easy points. We're in the home stretch now. Let's transition to our final debrief, focusing entirely on avoiding the most common pitfalls ATPL students face on test day. Here are the top mistakes, rapid-fire style. Mixing up track and heading, forgetting your wind corrections, neglecting to match your units of distance and speed, and finally, ignoring in-flight weather updates. Listen, eliminating just these 4 errors alone will vastly improve your exam scores, and it's going to make you a much safer pilot on the line. I really want to emphasize this operational reality. Assuming an ETA is fixed is a massive trap. Flight planning doesn't just magically end at takeoff. It is a continuous, dynamic process of observation and correction all the way to your destination. So today, we learned the structure of a perfect navigation log. Here's your quick recap. 1. Always know the difference between track and heading. 2. Follow the strict 4-step workflow to prevent pressure errors. 3. Update your ETA dynamically as winds change. And 4. Always watch your fuel units carefully. If you want more exam tips, subscribe.